I did this example on A1, and we went as far as getting the value of x as a positive and a negative 32. And I explained why we have to get two answers there. Okay? The main reason is because the value of the rational, that is the numerator of the rational exponent is even. Because of that, our final answer, it won't be one solution, but what? Two solutions. Right? So I explained that. Then for today, I'm not sure if I did this example too. You remember? Huh? I did B1 as well. Okay? I did B1 and I showed you how to use the K method, right, to solve that. Okay? Then, right, number 4, if there's anybody who did number 4, right, I'm just going to go over it now. If you did number 4, make sure you pay attention. So number 4, we have got x to the power of 4 over 3 minus 3x to the power of 2 over 3. As you can see, the denominator of the rational exponent is the same. But the first one, the numerator is a 4, the second one, the numerator is a 2. So you need to know that x to the power of 4 over 3, this can be rewritten as x to the power of 2 over 3 all squared.
So do you not put the brackets like...
Okay? Alright, sorry, the brackets must be covering the x as well. So it will be like that. So it's x to the power of 2 over 3 all squared. Okay? Then, from there now, by doing this, you are creating this x to the power of 2 over 3. That will help you to introduce the K method, because this exponential equation is very complex. So once you do this, then your K method, K is equal to x to the power of 2 over 3. Then you create a quadratic equation, okay, in terms of K, and that quadratic equation, it's a grade 9 quadratic equation. Okay, when you factorize it, you get two values of K. You get two values of K. Are you following there? Right? Then from here now, once you get your two values of K, please be aware that you have to test both of them. Because either both of them can provide you solutions for X, or one of them may provide you a solution for X. There's also a possibility that both of them may not provide you a solution for X. So you have to test all two. So if we start with K equal to 4, you get X equal to 2 over 3 is equal to 4. So the value of A, based on the first lesson, if you're paying attention, the first lesson. So can you do me a favor? I need your attention. Yes. Are you aware that your face can tell me that you are paying attention or not? Do you know that? And your body also tells me whether you are paying attention or not. Even me as your teacher, you can see that I'm interested in what I'm doing or not. You can see. And you can judge. Okay? So I need your maximum attention. Alright. So here, the numerator of the rational exponent is even. The denominator is odd. Okay? So what that means is, when we want to get our answer, okay, we have to put a plus or minus there. Because the numerator is even, the denominator is odd. So you have to put a plus or minus. Okay? So that in the end, your final answer will be both a positive 8 and a what? A negative 8. I'm going to repeat that, because this part here, it confuses learners. The numerator of the rational exponent is even. The denominator is odd. The number on the right-hand side is positive. Because the numerator of the rational exponent is even, it means we'll get two solutions for x. Will you stop that here? Okay, so we'll get our two answers. as x equal to plus or minus 8. Now you can ask yourself, but how come? Okay, that can be tested. You substitute positive 8 here. The cube root of 8 is a what? What is the cube root of 8? It's a 2. What is 2 squared? 4. What is the cube root of minus 8? Minus 2. What is minus 2 in brackets squared? Give you a 4. So you get 2 solutions. Now you can be tempted to put one solution, or you can be tempted to get one solution, but there are actually 2. Why are they 2? There are 2 reasons. One, this number here is positive. 2, the numerator of the rational exponent on the left-hand side is an even number. The denominator is odd. So we get what? 2 solutions. Then, is anybody else got a question? Yes.
Can you use the log to get over the plus and minus? If you don't write on those,
Okay, you may lose the mark if
for the final answer.
for the final answer, if the final mark is allocated for, it is allocated for both x values, you lose the mark for the answer. Because if you are supposed to provide 2, then you provide 1, you get a 0.
But you still get the marks
For working out, yes, but some parts you might not get a mark because you probably have missed the concept. If there are 2 solutions, then you must get 2. You must get 2 solutions. You don't give you a same mark. If there are 2 solutions. Unless if you get 2 solutions that are not for 8 and minus 8. Maybe that's when you can get a mark. Alright. Okay, then when k is equal to minus 1, pay attention, when k is equal to minus 1, x to the power of 2 over 3 will be equal to minus 1. Now here, we have got a problem. The number on the right hand side is negative. Okay? The numerator of the rational exponent is even and the denominator is odd. There's no solution there. Okay? We could only get a solution if the numerator was odd and the denominator was also odd. But in this case now, the numerator is even. The number on the right hand side of the exponential equation is a negative. So no solution. Is that clear to everybody? So I showed why we don't have a solution here. The reason why we don't have a solution, x to the power of 2 over 3 is equal to minus 1. If you move on and convert this exponent to a positive, you get x equal to minus 1 in brackets raised to the power of 3 over 2. Now, it's not possible to find the square root of minus 1. Therefore, there's no solution when k is equal to minus 1. Okay, that brings us to a mathematics concept, a math concept called complex numbers, which are not part of your curriculum. They are for people who study maths after high school. Okay? If you study BSc in maths or statistics, computer science, engineering, that's when you deal with such cases. Yes?
So no solution is the same as algebra.
Sorry?
No solution is the same thing as algebra.
Yes. Okay, so can I have your attention? Now, when you say there's no solution, it means the answer is not real. It's not a real number. Remember that in grade 8, 9, and 10, you were taught the real number system, isn't it? From minus infinity to positive what? Infinity. In this case here, the square root of minus 1, you cannot find it between minus infinity and positive infinity. It's a non-real number. In higher level maths, it's called a complex number. Okay, so there won't be any solution, or you can say the solution is what? Non-real. But there won't be any solution for you guys in high school. Yes? Maybe 5 or 6. Alright, then the other question, some of you did, if you did your work, then you can mark it. Number 7, we have got 3x to the power of 3 over 5 is equal to minus 24. Right? Make sure you pay attention carefully. The number on the right hand side is is negative, but the numerator is what? Is odd. The denominator is also odd. Therefore, we have a solution. Okay? If both the numerator and the denominator have what? Are odd, and the number on the right hand side of the equation, the integer, if it's negative, then you have a solution. So here, we convert this 3 over 5 to a 1. So I went back to the basics, but before I did that, I divided both sides by 3. So you get minus 8. Then you convert the exponent from being 3 over 5 to a 1 by multiplying 3 over 5 by its reciprocal. Then you must do the same on the right hand side. But make sure you put this minus 8 inside brackets. Okay, you put the minus 8 inside brackets. So you get minus 8 in brackets raised to the power of 5 over 3. Fortunately, we can find, see from here now, the cube root of minus 8, it's a negative 2. Negative 2 to the power of 5 will give you negative 32. Okay? Hello? I need to see each other's faces. Okay. I want to see your eyes. Are you following? Alright. Just to let you know, we have made some changes to your assessments in terms of dates. So please take note of this. Number 10. Okay. All right. Do you agree with that? All right. Okay. Let's do number 10 as requested. Right, you must guide me and tell me what that equation is. Can you stop talking, please?
So minus 16x
Minus 16x
to the power of
negative 2 over 3
plus.
this one here.
I don't know, they also
Are you sure about this?
they also free.
Huh? This one here. Okay, this question here, it's very easy. What you can do, pay attention. I would advise you to take the minus 16x to the power of minus 2 over 3 to the what? Right hand side. So that you can make it what? Positive first. Okay? So if you take the right hand side, we can write this as 16x to the power of minus 2 over 3 is equal to 4. It is the same.
So could you not make it difference between squares? Like, because you could like turn it into common factor of
Okay, if you want to make it, that's a good question. You know that almost every year I have to answer a question like that. Check this out. Can you pay attention carefully? If I give you x is equal to y, right?
Yes.
Do you agree with me that it means y is equal to x?
Yes.
It's the same thing as what I did. Okay? Look here. If I take the minus 16x to the power of minus 2 over 3 to the right hand side, I will end up having 4 is equal to 16x to the power of minus 2 over 3. So if 4 is equal to 16x to the power of minus 2 over 3, right? If I swap them in terms of what you want, this is the same as minus 16x to the power of minus 2 over 3 equal to minus 4. These two negatives, they'll what? They'll cancel out. Do you understand that? Huh? So from now on, please be aware that if x is equal to y, it means y is equal to x. Okay?
Yes.
Alright, let's carry on here. So the next thing, you can divide both sides by 16. Then you get x to the power of minus 2 over 3. This is equal to a quarter. Alright? Now, this exponent is negative. So I need to work with a what? A positive exponent. So this becomes 1 over x to the power of 2 over 3 is equal to a quarter. Are you following there? Yes. Now, look at this now. If the numerator here, sorry, on the left hand side is a 1, the numerator on the right hand side is also a 1. Am I right to conclude that x will be x to the power of 2 over 3 will equal to 4? Am I right to conclude that? Yes. You're so lost way now. Okay, dividing both sides by 16, is that clear to you? Then, okay. Alright. I'm sure you remember this law. X to the power of minus n is equal to 1 over x. So I've applied it from here, and I got this. Okay, look here. The numerator here is the same. The numerator is the same.
Yes.
Even if, okay, let's consider it this way. If I want to cross multiply, this denominator here multiplies the 1. This 4 multiplies the 1. So in the end, you come to x to the power of 2 over 3 equal to what? Equal to 4. Yes?
You don't treat it as a negative and then so then you times the 1 over 4 by minus 3 over 3.
Why would you want to work with? Okay, I don't encourage you to work with negative exponents. It's not a good idea to work with negative exponents. Okay? It's not a good idea to work with negative exponents. I hope you are following. Yes. Okay, so when you get to this point here, remember, how do you carry on? Right? You multiply this by its reciprocal. You do the same on the what? On the right hand side. So what this means, we should get two solutions. Do you see them? So we have to put a plus or minus there. Why are we getting two solutions? Because the numerator of the rational exponent, it's a what? It's an even number. Are you following? Yes. Okay, you missed 2 lessons. I think 1 or 2 lessons. Okay, so you get x equal to plus or minus the square root of 4 cubed. So your final answer, the square root of 4 is a what? Right, it's a 2, but it's a positive and a negative 2. So the final answer will be positive or negative what? 8. Are you following? Is that what you got? Those 2 answers. Okay? Now, yes?
So the table from this place on the person, right?
Yeah?
The table that you put on
Yeah, I think I put this document on the board. It was on Wednesday. As long as it's correct. Alright, listen. Joshua did it in a different way. He used a difference of 2 squares. So let's use a difference of 2 squares. Okay? So this will be method 1. Okay, that will be method 1. Method 2, you can do it the way that we did it. So we have minus 16x to the power of minus 2 over 3. Please just correct me if I'm right. Minus 2 over 3 plus 4. Can we have one lesson? All right, let me just tell you something. All right, so this is the same as 4 minus 16x to the power of minus 2 over 3. Okay, this will be equal to 0.
Oh, so you can also just take the whole form and then it becomes 16x minus 2 minus 4. I think it's just easier to walk through.
Yeah, it depends. You can do it this way, you can do it the way that you want. Now, in my case here, what I would do is convert the negative exponent to a positive, but the 16 will remain as the numerator. I hope you know. Do you see that the 16 is not affected by the minus 2 over 3? How many of you see that? The minus 2 over 3 does not affect the 16, it affects x only. Do you see that? So, if I use this law, x to the power of minus n equals 1 over x to the n, what happens is that the 16 will become my numerator and the x to the power of 2 over 3 becomes my what? My denominator. Okay, I might take a different route from the one that you do.
So
But
this looks more like way more complicated than the right.
in what way?
It's just more complicated.
Okay, let me tell you something. If we were to give you a test to answer that question, we won't get the same way of doing the problem. Do you know how many of you, okay, just to tell you, just to give you some numbers, I love numbers by the way. Yeah, we don't teach you that anymore, you know that. So this becomes 4x to the power of 2 over 3. Yes.
Shouldn't the 16 over x to the power of 3 give that bracket because we
No,
changed it from negative to positive?
no. Then minus 16. This is what? Now we can come to a difference of what? 2 squares. So how do I get the difference of 2 squares? This 4 here is a perfect square. The x to the power of 2 over 3 is also a perfect square. Okay, someone might be asking, how is x to the power of 2 over 3 a perfect square? Well, it's simple. How is it a perfect square? It's x to the power of 1 over 3 squared. Okay? So what that means is I can write this as 4x to the power of 1 over 3 squared minus 16 equal to 0.
Does the 4 not go in brackets?
No, it can't be in brackets because the 4 is like a coefficient. The 4 cannot be in brackets.
When you use a mark,
Yes, it will affect the whole question. So here, if I were to ask you, find the square root of 4 and x to the power of 1 over 3 squared, the answer would be 2x to the power of 1 over 3. There is a minus here, we put a minus. Then what's the square root of 16? It's a 4. Then you repeat the same, but you put a plus here. So that will be 2x to the power of a third plus what? 4. This will be equal to what? 0. Then you equate this one here to 0. You also equate the second one to what? To 0. Okay, let us put it to 0. Okay? Also, the other thing, I could have used the K method, by the way. You see, I could have used the K method as well. That could probably might have been simpler. But then from here, you get 2x to the power of a third equal to 4, or 2x to the power of a third equal to minus 4. Okay? Now, I hope you can see that we can divide both sides by 2. You see that? So if I divide both sides by 2, I'll get x to the power of 3 is equal to 2. The other one, it will give me x to the power of 1 over 3 is equal to minus 2. Okay? Then here, well, we have got these 3. Remember, it's a 3. Right? So I'll end up getting x equal to 2 cubed. And this one here, because the numerator is even, the numerator is odd, denominator is odd, I've got a solution. So that will be x equal to minus 2 cubed. Then here I'll get 8, and there I'll get negative 8. Okay, but this method is a little bit long, right? Look here. Okay, look here. If it was a test situation, someone sees the question in terms of how I did it now, and you still get to your 2 correct answers, you get your full marks. If someone had seen it based on the first method, okay, this one here, and you still get the answers, you get your full marks. But these two are not the only ways of doing the question. You can also use the K method. Okay? You can also use the what? The K method. You should also come to x equal to plus or minus 8. All right? Okay, so let me give Joshua an opportunity to